Alright, so we want to establish trigonometric ratio of the four quadrants, okay? So when I say four quadrants, alright, let me divide my board. Please follow me as I divide my board. So when I say four quadrants, I mean when we have our what we call it, when we have our Cartesian plane, I will decide to draw an angle in the first quadrant. That is, the angle for the first quadrant are angles that are from 0 degrees to 90 degrees. Can you see that? From 0 degrees to 90 degrees. Those are the angles at the first quadrant. So this is theta. Alright? Take note. From 0 degrees to 90 degrees. So now the second quadrant, let me put the second quadrant here. Okay, let me put the second quadrant here. Second quadrant are angles from they have gone beyond 0 degrees. They are now at the second quadrant here. Can you see? So they go beyond 0 degrees. So we see at the second quadrant, these are angles from what? 90 degrees to 180 degrees. Alright, so between 90 degrees and 180 degrees, those are angles at the second quadrant. So this is theta. Mind you, these angles, this theta is not really what you are interested in. You are interested in the angle that is to the horizontal, the angle to this horizontal. Alright? So what is the angle to the horizontal? What will be this angle? That will be, if here is theta, for instance, let's say here is 120, what will be this other angle? Remember, 120 is more than 90, right? But not up to 180. So 120 is an angle at the second quadrant. So if you have 120, this other angle, how do you get it? So this is straight angle, 180. So by the time you remove 180, by the time you remove 120 from 180, you will not get this other side. Alright? So all this angle at 180, you remove this 120, you will not get this other part. You understand it? And that will be 60. Alright? So we say that this angle is what? 180 minus theta, whatever theta is. You understand it? That's just an example. You understand now? So let's go to the next one. The next one, let me do the next one here. The next one will be third quadrant. Third quadrant is angle that goes beyond 190, 180, and to this part. Can you see that? So examples of that, those angles are angles that are 200. Can you see? 200 is more than 180. 200 degrees is more than 180. Alright? But it's not up to 270. This plane is 270. And each of those quadrants is 90 degrees. So each of those quadrants, okay, let me use my bigger board. Each of those quadrants is 90 degrees. This is 90 degrees. This is also 90 degrees. This is 90 degrees. This is 90 degrees. Altogether 360 degrees. You understand me? So now this plane, if you have 90, and 90 times 3, that's 270. So what I'm saying is that angles at the third quadrant are angles that move from 0 degrees to 180 and not up to 270 degrees. So that those are angles that are what? Angles at what? Third quadrant. I hope you understand that. Alright? So angles at the third quadrant, let me put it very well. Angles at the third quadrant are angles from here to this place. Alright? So remember, now this angle and this third quadrant, we are not really dealing with that. We are only dealing with what? The angle to the horizontal. So we are dealing with this angle to the horizontal, okay? So we are dealing with this angle to the horizontal. The angle to this horizontal, that angle. So if from here to here, from here to this other point, this point here is theta, then how do you get this only this one? How do you get only this one? So all we do is remove this straight angle. What is this straight angle? This straight angle is 180. The straight angle is 180. So remove 180 from theta, then you now get this one. Everything from here to here is theta. From here to here is theta. Alright? So remove 180 from theta, you now get this small angle. So now let's do that. So we have that one. We have that one. Theta minus 180. Theta minus what? 180 degrees. Theta minus 180 degrees. That is the angle here. The small angle here from here to here. theta minus what? 180 degrees. I hope you understand that. So now let's go to the fourth angle. The fourth quadrant, let's draw that fourth quadrant. The fourth quadrant are angles from where? From this place to this place and to this place. Can you see that? This one is 180 degrees less than theta less than 270 degrees. Can you see? This one is now what? 270 degrees less than theta less than what? 360 degrees. That's the fourth quadrant. So which angle do I need? I need the angle to the horizontal. Take note. You need the angle to the horizontal. This one here. So how do you get this one? If I have everything here, how do I get this one? All together, everything is 360 degrees. So if I remove theta from 360 degrees, I will have this one. So I'll say 360 degrees minus theta. You can see that all these angles, they have different ways of getting their angle to the horizontal. Different ways of getting what? Angle to the horizontal. I hope you understand that. So let's take them one by one. This is my first quadrant. Let's start with this one now. Alright? So my first quadrant are angles from what? I hope you can see that one. My first quadrant are angles for what? Angles from what? 0 to 90 degrees. So let's establish our ratio for the first quadrant. Now the ratio in the first quadrant is, remember this is y. This is y. When it goes up, it's positive for y. But when it comes down, it's negative for y. Negative for y. When it goes right, it's positive for x. When it comes left, it is negative for x. So this is positive y and positive x. Okay? Positive y and positive x. So first of all, we will say for the first ratio of sin theta is what? Opposite. This is opposite. Opposite to this angle. Opposite over hypotenuse. Your hypotenuse is r. All your hypotenuse are r. They are all r. This is r. Okay, so sin theta is what? Opposite over hypotenuse. R over 1. Now, take note. This is positive. This is what? Positive. Can you see? It is positive. So cos theta, let me start with tan. Tan theta. Tan theta is what? Opposite over adjacent. This is opposite, this is adjacent. So this is y over x. The value, whatever value you get for that will be positive. Alright? It will be what? Positive. Now this is the next one, cos theta. Cos theta is what? Cos theta is what? Adjacent over hypotenuse. So what is your adjacent? Your adjacent is this one, and this is your hypotenuse. That's x over r. So x over r, that also is positive. So we say at the first quadrant, A, all are what? Positive. All the trigonometric ratios are positive. A for the first quadrant. All of them are positive in the first quadrant. Are you getting that? Now let's move to the second quadrant. The second quadrant you can see. So when you want to get the second quadrant angle, you must know that the second quadrant angle is what? 180 degrees minus theta. So if I give you sin theta, it means that you must reduce it to sin 180 degrees minus theta. The same thing for sine, cos, and tan. Are you with me? I hope you get that, right? So cos theta is what? Cos 180 minus theta. Tan theta is also what? Tan what? 180 minus theta. Can you see that? Alright? So you have to reduce it. What does that mean? Let me give you an example. If I have 120 degrees, this is from here to here is 120 degrees, right? So what will this place be? This is the angle I'm looking for. I'm looking for the angle to the horizontal. This is the line, alright, that separates this angle and this other angle. So the angle I need is the angle to the horizontal. And to get this angle to the horizontal, I will say 180 minus this theta here. So that's what I'm saying. So if I have 120, if I reduce 120, that will be what? 180 minus 120. That will give me what? 60 degrees. So if I have sin 120 degrees, then it means that I'm obviously looking for what? Sin 60 degrees. Do you understand that? Now, let's look at the values of the trigonometric ratio. Alright? Let's look at the values of the trigonometric ratio. At this point, sin theta is what? Opposite, which is y. Remember, this is positive y. This is positive. Alright, remember this is positive y. When it goes up, y is positive. When it comes down, y is negative. When it goes up, y is positive. When it comes down, y is negative. So it's going up. This is positive y. So y over r sin theta. Opposite over what? Hypotenuse. So y over r. That is what? Positive. Can you see that? That is positive. There's no negative value there. Now let's do for what? Cos theta. Let's do for cos theta. Now cos theta is what? Adjacent over hypotenuse. This is adjacent, this is hypotenuse. Now this is positive x, this is negative x. So you can see that this adjacent is negative x. This adjacent is negative x. So you have cos theta as negative x over r, over r. Adjacent over hypotenuse, negative x over r. So that is why at the second quadrant, cos is negative. So this place will be negative. Minus. So when you are using the angle, it will be minus cos theta. What does that mean? That means that, let me do it here. That means that if I have theta as 120 degrees, and I'm looking for cos of theta, cos of 120 degrees, I will reduce it to what? Cos minus cos 180 minus 120. So that will give me what? Minus cos 180 minus 120, that will give me what? 60. So therefore cos 120 is taken as negative cos 60. You see the implication of everything we are doing now. So cos 120 is what? Cos negative 60. Meanwhile, the sign is positive. If it is sign, it's going to be positive. It's not going to be negative. You can see it here, right? Clearly. Alright, let's continue. So for tan we have that tan theta, remember tan is opposite over adjacent. This is opposite and this is adjacent. So opposite is y and adjacent is x. So this is negative x and this is positive y. So y over negative x. The whole answer is negative. This one is negative, right? That's for cos. Tan is negative. Can you see that? So just like what we did there, tan 120 will be minus tan 60. You understand that now? Good. So here will be negative minus tan what? Y equal minus theta. You understand that? I hope you understand that, right? Good. So we are done with the second quadrant. Now let's go to the third quadrant. You know what? Third quadrant. So let's explain the third quadrant here. Now focus here. This is our place now, our point of focus. Now at the third quadrant, you can see this is the third quadrant, right? What is third quadrant? Third quadrant simply means angle that goes beyond 90, 180 and comes to this point, right? So when it comes to this point, this is what you are trying with, just this angle. You understand me? That's what I'm saying, just this angle. Are you getting me? So to get this angle is remove y equal from theta. Remove y equal from theta. So to get the angle at the third quadrant, we say theta minus y80. This is y80. The angle above is y80. So just remove it. So this will remain. That will be the angle you are looking for. The angle to the horizontal. Okay? So we say therefore, for sin theta, we say what? Sin theta minus y80 degrees. Alright? Let me give you an example. If you have sin 210. 210 is angle at the third quadrant. Alright? How do you derive this angle? You say sin 210 is the same as what? Sin 210 minus 180. You understand that now? So that will give you what? 210 minus 180, that will be 30. So that will be sin 30. Alright? So let's look at the value, whether it is positive or negative at the third quadrant. I hope you understand now. So let's check. So let's check. We have to check. So let's check. So we have now this is opposite to this angle. This is opposite. And remember, all this while we have been having y up. That is positive y. Now y is coming down. Y is the vertical line. The vertical line is coming down. So that is negative y. Are you getting me now? So this is negative y and this is negative x. By the time it goes left, that is negative x. This is positive for x. Alright? So sin theta, which is opposite over hypotenuse, right? That will be what? Minus y over r. Can you see that is negative? That's negative, right? That is negative, right? So let's go to tan. Tan theta. So remember this is minus negative. Tan theta, that will be tan theta minus 180 degrees. Alright? So let's look at tan theta. Tan theta is what? Opposite over adjacent. So this is opposite, minus y minus s. So minus y minus s. Minus will cancel minus. That will be positive. Can you see that? So that will be what? Positive. So the value for tan is positive. So there we have positive. You don't need to put minus. So we have cos theta. Let's do for cos theta. Cos theta is what? Adjacent over hypotenuse. This is adjacent, negative s. So let's break it up. So we have cos theta minus 180 degrees. Alright? That's the one. Minus s over r. That is minus s over hypotenuse. Adjacent over hypotenuse. So minus s over r, that is negative. Now, you discover that at this third quadrant, at the what? Third quadrant, tan is positive. So we say C. Remember here we say A, all of them are positive. At the first quadrant, all of them are positive. At the second quadrant, only sign is positive, so we say X. At the third quadrant, only tan is positive, so we say T. Then we are done with that. Let's move to the fourth quadrant. That will be the final quadrant, the fourth quadrant. Now, at the fourth quadrant, we are dealing with what? Let me do that at first. So, at the fourth quadrant, we are dealing with what? Angles that have gone beyond 90, 180, 270, and up to this point. Alright, so that is theta. Okay? So, remember, all we need is our angle to the horizontal. This is the horizontal line. We are looking for the angle to the horizontal. So, how do we get this angle to the horizontal now? So, if everything here is theta, how do we get this angle? So, we just say 360 degrees minus theta. Okay? So, let's go. So, sin theta is equal to what? Sin 360 degrees minus theta. Okay? So, let's get the ratio. Now, this is y is down, this is minus y, but this is positive for s. So this is plus s, positive for s, and this is our r. Our r is always positive. Okay? So sin theta is what? Opposite over hypotenuse, that's minus y over r. That is what? Negative. Can you see that? Negative, right? And let's go to tan. Tan theta. So this is negative, right? So let's go for tan. Tan theta is what? Tan 360 degrees minus theta. Okay? That will what? That will what? Opposite over adjacent, that's minus y over x. Minus y over x. So that one too is what? Negative. Can you see? That one too is negative. Just like sine is negative. Let's go to cos. Cos theta. Let's see cos theta. Let's see what we get. So what is cos theta? Cos theta is what? Adjacent over hypotenuse. This is adjacent. This side is opposite. This is adjacent. So this is hypotenuse. So adjacent over hypotenuse. This is positive x. That is x over r. That is positive. So at the fourth quadrant, cosine is positive. At the fourth quadrant, cosine is positive. What is the implication of that? I want to give you the implication of that. So let me rub off this little part. That means that if I have my theta as 300 degrees is angle at the third quadrant because it has gone beyond 270. This is 270. Alright? Alright, so I didn't establish that. Let me establish it. Angles at the third quadrant are angles 270 less than theta, less than 360 degrees. So it can go beyond 270. So angles from 270 to 360 degrees, these are angles that are at the fourth quadrant. So if you have sine 300 degrees, how do you get that? So you just say sine 300 degrees. Remember, at the fourth quadrant, sine is negative. Sine is negative. So if I have sine 300 degrees, that means that, remember, at the fourth quadrant, sine is negative. So I'll have equal to minus, that is the minus sine what? Then you reduce the angle. You reduce it by saying 360 degrees minus theta. Now 360 degrees minus 300. Alright, that was what? Minus sine 60 degrees. So it means that minus sine 60 degrees is the same thing as sine 300. And if you want to confirm that, use your calculator and press sine 300. The answer is there for sine 300, the same answer is there for minus sine 60 degrees. You understand that now? So let's solve 5 questions and see how we apply everything we have done now to that question. Now, before we solve that question we want to solve, let's do trigonometry of special angles. Special what? Angles. So what are the special angles? We have 0 degree, 30 degrees, 45 degrees, we have what? 60 degrees, and then 90 degrees. Of course, we have y and more. Right? But these are the focus we have now. These are focus on this. So, sine 0 degrees is 0. Cos 0 degrees is 1. Take note. Tan 0 degrees is what? 0. Okay? So, cos is 1. Now, let's go for 30. Sine 30 degrees is 1 over 2. Take note, 1 over 2, write it down. Sine 30 degrees is 1 over 2. Cos 30 degrees is root 3 over 2. And tan 30 degrees is what? Root 3 over 3, right? Okay, root 3 over 3. That is what? 30 degrees. Now let's go for 45 degrees. Sine 45 degrees is root 2 over 2. Cos 45 degrees is root 2 over 2. Then tan 45 degrees is 1. Take note of that, alright? So let's go to the 50. Now, sine 60 degrees is root 3 over 2. That is 0.8660. Cos 60 degrees is 1 over 2. And tan 60 degrees is root 3. Okay? Root 3. Basically, these are the angles we need. Alright? We still have sine 90. Alright? But, 90 degrees. But these are the angles we need to solve some questions. So, I'm going to use these angles to solve some questions.